The largest building in the world, by volume, is the Boeing 747 plant in Everett, Washington. This building measures approximately 631 meters long, 646 meters wide, and 34 meters high. What is its volume in cubic centimeters? So this problem at its heart is a conversion problem, and since it involves volume, we will write first of all the formula for finding the volume of a rectangular prism. So the formula for volume is equal to the length times the width times the height, and we're given this information in meters and we're asked to convert it to centimeters. So let's first write down that the length is equal to 631 meters. The width is equal to 646 meters. And the height is 34 meters. Now we're faced with a choice of whether we convert these dimensions, the length, the width, and the height, from meters to centimeters here, or if we convert these measurements as we go along. So let's, I'm going to make the fence post setup, and I'm going to get ready to measure, to write out length, width, and height here. And let's convert them as we go along. So first of all, I'm going to write 631 meters, and then I need a conversion factor for 631 meters, and I'll make it as a fence post, and it needs to be the fraction equal to 1. So I'll write 1 meter is equal to 100 centimeters. And the reason centimeters is because we're asked to convert or to express our answer for the volume in cubic centimeters. So we need centimeters. So I have this first measurement, which represents the length, and now I'll do the width, so 646 meters, and I'll put another fence post in that converts this by a fraction equivalent to 1 meter, and it's going to be the same one, 100 centimeters. This fraction and this fraction are both equivalent to 1 and allow me to cancel out meters and meters, meters and meters. And for the last one, I'll put 34 meters of height, and the last fence post with the same conversion factor, 1 meter equals 100 centimeters, and I'll cancel the meters. And I'm now ready to multiply across. So what I could say is I end up here with 631 times 646 times 34 meters times 100 times 100 times 100. But let's notice something here. 100 is equal to 10 to the second power times 10 to the second power times 10 to the second power. And so using our rules for multiplying exponents, where if we're multiplying exponents with the same base, what we can do is simply add the exponents. This is equal to 10 to the 6th because 2 plus 2 plus 2 equals 6. So I could enter this calculation as 631 times 646 times 34 times 10 to the 6th. And that actually saves me quite a few steps. It makes it a little bit more efficient to type into the calculator. So let's see what happens here. 631 times 646 times 34. Now if I want to multiply by 10 to the 6th, the way I can do that on my calculator is multiply by 10 and then use the exponent, the caret button here, raise it to the 6th power like that, and then type enter, and I am given my answer. Since I'm set in scientific mode, I'm given my answer 1.3859 times 10 to the 13th. So I'll write down several of these digits, 1.3859 times 10 to the 13th. In other words, e to the 13 is equal to 10 to the 13th. Now I've got a lot of extra digits, and I need to decide in terms of significant digits, what am I going to be using? Well, if I look back up here, 631 has 3 significant digits, again 3 significant digits, 2 significant digits. So what I need to do is round this answer to two significant digits, two sig digs. So I'll go ahead and say equal to, and this is going to round to 1.4 times 10 to the 13th. Oops, 10 to the 13th. And we were asked for cubic centimeters, so centimeters cubed. And when I do my therefore statement, I'm going to say, therefore, the Boeing plant, the 747 plant, its volume is 1.4 times 10 to the 13th cubic centimeters.